Right, Border Gateway Protocol, BGP, Border Gateway Protocol. This is also a routing protocol as we already discussed in the previous class. This is also a very good routing protocol intended for internet. This is a protocol designed to meet the needs of the internet routing policy. When we talk about internet, it's public network. So when we route our traffic, we may have some policy going through the public network. So those policies can be enforced with the protocol called BGP, BGP Border Gateway Protocol. This is one of the reasons why BGP is very good and very important protocol for internet. We got a lot of attributes. As a metric. If you take OSPF, we got a metric called cost. If you take EIGRP, we got by default bandwidth and delay. Likewise, in RIP, we have hop count. So there is no as such metric in BGP. It has got a rich metric called attributes. We do not call it as metric, we call it as attributes. Rich metric, very rich metric. And this attributes are like plug and play. Whenever you want, you add it. Whenever you don't, you just leave it. Attributes makes BGP a special protocol. And not only that, the design itself is very extraordinary, meaning this protocol will not use any multicast address and flood hello packets and discover neighbor. This will not do that. This will not flood any hello packets and discover neighbor as EIGRP and OSPF and RIP does. It won't do like that. This is straightforward. It uses TCP. So if you have TCP, it needs to establish connection. If you want to establish connection, first of all, you need to know the destination. So neighbors are not dynamically discovered in BGP. We have two flavors of BGP. One is IBGP, Interior Border Gateway Protocol. The other one is EBGP, Exterior Border Gateway Protocol. Now each flavor of BGP has got different administrative distance. IBGP is 200 and EBGP is 20. So from this itself we can understand that this is a recommended protocol to run external. External to what? External to autonomous system. When we have an autonomous system, what is autonomous system? Group of routers under a common single administrative control, or group of routers having common policies governing them. That's what autonomous system. Now when we have multiple group of routers, we call it as an autonomous system. Likewise, our neighbor enterprises also has got group of routers, and that is another autonomous system. There is another neighbor having group of routers and an administration to control it, and this is another autonomous system. Now between this autonomous system, the protocol that is recommended is BGP. BGP is a protocol that is meant to run between autonomous system. So if you run BGP between autonomous system, then we call that BGP as EBGP. And if I'll run BGP within the router within the autonomous system, then I call it as, if I run BGP within an autonomous system, I call it as IBGP, Internal Border Gateway Protocol. As I already mentioned, BGP uses TCP. because it uses TCP and port number 179, the neighbor need to be statically assigned. Neighbors are not dynamically discovered, always. Not dynamically discovered. Always, whether it is IBGP or eBGP, we need to provide neighbor information manually. So neighbors are assigned manually, statically, always, because it's TCP. So there is no point of thinking about a multicast address used by BGP. Why? BGP need not to use a multicast address to discover a neighbor, because neighbor we only give. Then you may have a question, then why I need a routing protocol if it is not going to discover neighbor dynamically? See, discovering neighbor dynamically is not the job of routing protocol. The job of routing protocol is to route the packet, is to discover the route for various destinations. So if it discovers route dynamically and if it forms neighbor dynamically, then there is no security. It is good if it discovers neighbor dynamically, but not good between autonomous systems. It is good within your autonomous system because it's a secure network. It is good to learn multiple networks of various destination dynamically within the autonomous system. But it is not good to learn the network information for various destination dynamically from a public network. So neighbors are statically configured, and only if that neighbor advertises a network, a router can learn that network. It won't simply learn the network given by anyone. So whomever the neighbor we configure on a router, only from that neighbor router, updates can be taken. So this is more good when it comes to forming neighbor, establishing route in a public network. So BGP uses 179 TCP, port number 179, and the neighbors need to be statically configured. No dynamic discovery of neighbor. This rule is for both IBGP and eBGP. Now because it uses TCP, the neighbor need not to be a directly connected neighbor, because it uses TCP. See, we have Telnet. What is Telnet? Terminal emulation, meaning I emulate a remote device. I emulate a remote device locally. I see the remote device locally. That is what Telnet. Now to do Telnet, do I need to Telnet my very next machine first, and then the next machine, and then the next machine? No. To Telnet from here to a far distance device, I need not to Telnet to the nearby device. I can straight away Telnet to the far remote device. So same like that, Telnet uses TCP. Here BGP also uses TCP. If there is a reachability, if there is an IP path already established, then I can discover. I can associate with a neighbor. So BGP uses TCP. Because it uses TCP, neighbors are statically configured, and that neighbor need not to be directly connected, can be a remote device also. So let's take one example here. When we have 3-4 routers like this connected, and let's say all these routers are in an autonomous system called 10. Let's say this router name is 1, 2, 3, 4. Now what I was saying is router 1 can form neighbor with router 4. We call it as BGP peers. Router 1 and router 4 are BGP peers. BGP neighbors. Now, for having neighbor between R1 and R4, to form neighbor between R1 and R4, alright. So BGP can form neighbor even if they are not directly connected. Means what? Router 2 and router 3 are there in between router 1 and router 4. Still router 1 can shake hand with router 4 without shaking hand with router 2 and 3. This is possible if it is any TCP protocol. As you can tell it from R1 to R4, you can also form BGP neighbor between R1 and R4. Both Telnet as well as BGP uses same TCP. What is needed for you to Telnet from R1 to R4? You need a reachability. First of all, you need to ping R4. If there is an IP path, then you can Telnet. Same way, if there is a reachability between R1 and R4, if R1 can ping R4, then it can form BGP neighbor, BGP peer. Now, how can you provide IP path between R1 and R4? By running any IGP protocols. IGP protocols like OSPF, EIGRP or RAPE. So when I run EIGRP or RAPE or OSPF on these networks, on these routers, I am able to ping from R1 to R4. If I am able to ping from R1 to R4, then I can also form BGP neighbor between R1 and R4. So BGP works on top of TCP. So if there is an IP path, it can form neighbor. How? By first of all doing a handshake, three-way handshaking. TCP IP three-way handshaking will happen between R1 to R4. And then it will start sending BGP open message, and then open confirm will be coming from the opposite side. Once the open confirm comes, they start sending the update, receiving the update, and they establish neighbor. So BGP is a connection oriented protocol. It uses TCP 179. Right. Now there is a condition here. When you enable a eBGP, what is eBGP? As we already discussed, eBGP is BGP running between different autonomous system, or BGP enabled on two router, that is in different autonomous system, not in the same autonomous system. Two routers forming neighbor, and these two routers are not on the same autonomous system, then it is eBGP. Now for eBGP, the neighbor need to be directly connected. Neighbor need to be directly connected. Why neighbor need to be directly connected? Here we see for iBGP, see this is autonomous system 10. I run BGP on R1 and I run BGP on R4. Then it is called as iBGP. In here I'm not seeing neighbors directly connected. R1 is connected to R2. R4 is connected to R3. So R1 and R4 are not directly connected. Then how it can form neighbor here, and why it will not form neighbor if eBGP neighbors are not directly connected? This is one important fundamental foundational question that we need to know. So eBGP neighbors need to be directly connected, whereas iBGP neighbor need not to. iBGP neighbor neighbors need not to be directly connected. Need not. Why? Why is, for security reason, how BGP is designed is, when it tries to form neighbor with other autonomous system router, the packet is sent with TTL of 1. When BGP tries to send a packet to an IBGP neighbor, when it tries to send the packet, it sends with the TTL of 255. When it is sending to an eBGP neighbor, it sends with TTL of 1. When it sends to an IBGP neighbor, it sends with a TTL of 255. This is the secret. Because the TTL value is 1, in eBGP, as soon as the packet hits the other router's interface, if it is not finding the neighbor, packet expires. It cannot form neighbor. So, to have some control, to make sure that we are forming neighbor with a known person, it is designed like this, with a TTL of 1 by default. But we can tune it, we can change it in two different ways, which we'll be seeing later in advanced BGP. Now, eBGP, the TTL value by default when the packet is sent is 1. For IBGP, the TTL value is 255. For this reason, eBGP neighbor need to be directly connected to form neighbor. IBGP neighbor need not to be directly connected. Right. Next, BGP sends keep alives every 60 seconds. Once the neighbor is established, it sends keep alive packets every 60 seconds. It will send keep alives every 60 seconds. Now, how to configure BGP on two routers? Let's say I got two routers and this router belong to AS1, Autonomous System 1, and this belong to AS2. Now how I'm going to form neighbor between these two routers? Now when I go to this router, and say router BGP 1 neighbor 10.0.0.2 remote AS remote AS 2. When I type in this command, this router 1 understands that it has got an eBGP neighbor. There is no special command to say this is an eBGP neighbor. How? It compares its own autonomous system number with the neighbor's autonomous system number. Both for IBGP and eBGP, we use the same command, remote AS. Even for IBGP, I use the same command. Let's say we have another router here called 10. And this has got 100.0.0.10, 100.0.0.1. Now when I say neighbor 100.0.0.10 remote AS 1, then R1 router will send the packet with TTL of 255, because this is the same number, same AS, IBGP. Both for eBGP and IBGP, the command looks same. The command is same. Then how a router will know that I am forming neighbor with an remote autonomous system or different autonomous system or the same autonomous system? By seeing this number. It compares its own autonomous system number with a neighbor autonomous system number. If that matches, then it is IBGP. If it is IBGP, in the outgoing BGP traffics, the TTL will be 255. So neighbor need not to be directly connected. Neighbor can be anywhere between 1 to 255 hops. Whereas when it finds the neighbor as the different autonomous system, it will send the traffic, it will send the BGP messages with a TTL of 1. So if the neighbor is seen very adjacent to this, then it forms neighbor. If the neighbor is far away, then not. So this is more secure. And this can be altered in two different ways. There are commands like eBGP multi-hop and TTL security. There are two commands, eBGP multi-hop command and TTL security command. There are two different ways in which they work to solve this problem. We'll discuss about this when we come to the advanced level of BGP. Now we understood the power of this number. It is this number makes a router to decide whether this particular neighbor is a local autonomous neighbor or a remote autonomous neighbor. Next, whenever we have redundant paths like this, let's say R1, R2, R3, R4, R5. So when we have routers like this, we always have mesh topology like this in a big network. Whenever we have like this, we have multiple paths to reach various neighbors. Say for example, R1 here can reach R3 in two different ways. It can go via router 2 and from router 2 to router 3. It can go via router 4, 5 and router 3. There are two routes, route 1, route 2. Now when we have multiple paths like this, if I'll go to this router and say, let's say this IP address is 23.0.0.3 and this IP address is 53.0.0.3. Now if I go to R1 and say neighbor is 23.0.0.3, remote AS 10. Let's say all these are in same autonomous system 10. So I'm going to router 1 and saying router BGP 10 neighbor 23.0.0.3 remote AS 10. When I say this, R1 understands that it's an IBGP neighbor and it sends the packet, TCP packet with 255 hops TTL value. And when R3 also has a neighbor statement, let's say here 12.0.0.1, and in R3 I'm saying neighbor is 12.0.0.1, remote AS is 10. Now when R1 sends a traffic, let's say it sends with the source address of 12.0.0.1. R1 is sending packet out. When it sends the packet out, it will take the exit interface address. It sends with 12.0.0.1. When the packet goes to R3, R3 will compare the incoming source IP address with a neighbor list. If it matches, only then it will try associating with R1. R1 is sending an open message. Only if R3 finds R1's address in the neighbor list of R3, R3 will say yes, it will confirm the open message. If R3 has no neighbor statement for that particular neighbor which sends the packet will not be entertained, it will be ignored. So let's say both the side neighbor addresses are configured and both the side autonomous system is 10 and everything is good. Now they form neighbor. R1 and R3 are neighbors. Let's assume R2 goes down or this link goes down. Something happens to this path 1. What will happen is we will lose the neighbor. We will not have neighbor. We lose neighbor between R1 and R3 because the path is gone. When this router R2 goes down, this link goes down. If this link goes down, 23.3 goes down. Now there is no 23.3, so neighbor goes down. So whenever we have redundant path like this, we can use loopback address, loopback interface address. So when we have loopback interface address, what is the advantage? Even if this link goes down, I can still reach that loopback interface via path 2. Because I have reachability via other path, I'm having neighbor. I'm not losing connection, neighborship. So using loopback interface address is a clever idea. The reason is the loopback interfaces or logical interfaces, they will go down only when this router goes down. If any one of the path is there, BGP will be there. It won't go down. So we need to use a loopback address. But there is a problem when we use loopback address, loopback interface address. What is that? When R1 sends the traffic, it will send with the exit interface address. Now what is the neighbor address of R3? Let's say the loopback interface address on R1 is 1.1.1.1. Loopback interface address of R3 is 3.3.3.3. Now what we decided is we decided to use loopback interface address instead of physical interface address. So I'm saying on R1 neighbor is 3.3.3.3. On R3 I'm saying neighbor is 1.1.1.1. Good. We are trying to use loopback interface address, that is good. But there is a problem here. What is that? R1 will try to form neighbor with whom? 3.3.3.3. We are running OSPF on this loopback interface, on everywhere. So R1 can ping 3333, so it sends the packet to form a BGP session to whom? To 3333. So R1 is sending a packet to 3.3.3.3 with the source of what? With the source of the exit interface address 12.0.0.1. Now when this packet reaches R3, what R3 will do first thing is it will compare the source address with the neighbor statement. It is not matching. Because it is not matching, cannot form neighbor. So there is a solution for that. What is that? Instead of sending with the exit interface address, you put your loopback interface address. When you put your loopback interface address and send to R3, R3 will compare the incoming source address with the neighbor list. Because it matches, now it will form neighbor. Now how to make BGP to assign the loopback interface address as a source address? There is a command to do that. What is that? Same command, neighbor. Whenever you send any traffic to 3.3.3.3, use update source. Update source command. Update source as loopback 0 interface address. So when we say update source loopback 0, whenever the packet is sent to 3.3.3.3, the loopback interface of R1, which is 1.1.1.1, that will be assigned instead of assigning the exit interface address. Likewise, we also need to do on R3. What is that? Neighbor. Whenever you send the traffic to 1.1.1.1, update source loopback 0. When we say that, it will use the loopback interface 0 address 3.3.3.3 and send the traffic. That 333 is matching with the neighbor statement here on R1 and they form neighbor. So we learned here the use of update source command. Right. Now I'm going to demonstrate this. And before I demonstrate this, we'll take one more scenario. See, now I got redundant paths between eBGP. This is not iBGP, this is eBGP. This belongs to AS10, this belongs to AS20. Now wherever we have redundant link, it is recommended to use what? Loopback interface address. So here it is, let's say 3.3.3.3 and here it is 4.4.4.4 and here IP address may be 34.0.0.1, 34.0.0.2, 43.0.0.1, 43.0.0.2. Now when I go to this router, let's say router 3, this is router 4. When I go to router 3 and say neighbor is 4.4.4.4, remote AS is 20. Neighbor 4.4.4.4, update sources loopback 0. Make sure you ping from R3 to 4.4.4 and from R4 to 3.3.3.3. Further, you can run any routing protocol, any other IGP protocols, only in between these physical to interface and logical interfaces, loopbacks, or you can use a static route. Static route is more secure. Now, I'm doing this on the other side also. On the other side, on R4, what we say is, we say neighbor 3.3.3.3, remote AS is 10, neighbor 3.3.3.3, update sources loopback 0. Now when we say this, what happens? Nothing will happen. They won't form neighbor. Why? Because it is eBGP neighbor. You remember we saw that today, we saw sometime before, eBGP need to be directly connected. eBGP neighbors need to be directly connected. But here in our scenario, we don't have eBGP neighbor directly connected. 3.3.3.3 is not directly connected to 4.4.4.4, meaning R3 is not directly connected to the neighbor address of the neighbor. Neighbor address for R3, the neighbor address is 4.4.4.4, which I don't see in the direct connected interface. So when the packet goes to this interface, it expires without seeing the neighbor. So what is the solution? As I already told, we can change the TTL value. That's the solution. So what we do is we say neighbor, whenever you send to this eBGP neighbor 4.4.4.4, use eBGP multi-hop command. eBGP multi-hop 2. When you say eBGP multi-hop 2, the packet will be sent with TTL value of 2. Similarly, do it on the other side. Neighbor 3.3.3.3 eBGP multi-hop 2. Now when we say that these two will form neighbor, when the packet goes from here to this interface, it's 1 TTL, and still the packet is still alive to find where is 4444, and they form neighbor. So this is what need to be considered when we use loopback interface. In iBGP, you need not to use eBGP multi-hop command. The reason is, by default it sends with TTL of 255. The packet is not going to expire. Whereas in between eBGP neighbors, the packet will expire because the packets are sent with TTL of 1. So we need to increase the TTL value so that the packet will never expire once it touches the neighbor. It will not expire. It will have the life to find the loopback interface address. Right now I'm going to demonstrate this and show you and confirm what we have learned so far. Alright, so this is a topology that we are going to use to understand what we learned so far. We got 4 routers. I'm going to quickly configure each router. I'm going to say enable interface fast Ethernet 0/0. This I'm doing for router 1. IP address will be 12.0.0.1.255.0. Interface fast Ethernet 01. No shut. IP address. I made a mistake actually. I want to keep it as /8. There is no reason because I have written on the board I'm doing /8. I can also have 24. Alright, I'm going to have loopback interface. Let's say loopback 0 on router 1 will have like this. It will have the router ID. IP address, the router ID is 1, so I'll say 1.1.1.1. Can be any mask, I'll just give /8. Alright, that's it. Now I'm going to paste this on router 1. Alright, so router 1 is ready. Let's go to router 2. Router 2 also has got the same interfaces. 0/0 will have 12.2 and 0/1 will have 23.2 and loopback interface will have 2.2.2.2. I'll copy this and paste it on router 2. Alright, So the other two routers, let's finish. Router 3 has got 4 interfaces physically. So let me copy this. /0 has got 23, 3, and 01 has got, 0/0 has got 13 here, and 01 has got 23, that's right, 23, 3 here, and 010 has got 43, 3, and 11 has got 34, 3. Right, the loopback interface will have 3.3.3.3. I'll copy this and paste it to router 3. Alright, so router 3 is ready. Let's go to router 4. Router 4 has got 2 interfaces only. One is fast Ethernet 0/0. 0/0 has got 43.4 and 1/0. 0/1 has got 34.4. Alright, so far what we have done is just basic IP addressing, but there is some more thing need to be done before we get into BGP. What is that? Reachability. If you want to form neighbor with a remote device, you need to have reachability. Now R3 cannot ping R1. Yeah, I can ping because I got direct connection, but I cannot ping through R2. I need some routing protocol. So let us run some routing protocol here. You can have RIP or EIGRP or anything. Let's take OSPF. I'm going to say on all the routers enable config router OSPF 1 network sorry, yeah, I can do this. Area 0. So when I say this, it will run all the network in that particular router. Any network, any subnet mask. So this I'll paste from router 1 first. Router 1. And also on router 2. I cannot do that on router 3 because I don't want to run OSPF here. I don't want to run no OSPF here. So what I'll do is I'll go and manually configure OSPF there on R3. router OSPF, router OSPF1, network 23.0.0.0, 0.255.255.255, area 0, network 13. And also remember we got a loopback interface with 3.3.3.3, so that is also mentioned. Alright, OSPF is running. Because OSPF is running, now I can ping from here, ping 1.1.1.1 with the source of 3.3.3.3, which is between loopback to loopback on R1 and R3. I'm able to ping. Now I can form neighbor. See, I'm going to form first of all IBGP neighbor between R1 and R2. I'm saying router autonomous system, router BGP. And let me tell you one thing, if I mistakenly create an autonomous system called BGP, if I want to create now another one, it won't allow. If I say router BGP 10 now, it will say no, only one BGP on a router. Already it is running autonomous system 1. It won't allow autonomous system 10 to be created now. So first of all I need to remove it. And here now I'm going to say neighbor is 3.3.3.3. Instead of using the physical interface address, I'm using the loopback interface address of R3, so that if any one of this path is available, either straight path or going through R2 is available, any one of this is available, I'll have neighbor. Remote AS even for IBGP the command is remote AS. Then how it will know that it is IBGP? It knows as IBGP by comparing the autonomous system number. Now why it is showing this error? I am typing this 3333 on router 3 itself. I should have said 1111. I thought I'm configuring on router 1, but I'm in R1, but I'm in R3. Alright, so neighbor 1.1.1.1 remote AS 10. Similarly on R1, I'll say router BGP 10, neighbor is 3.3.3.3, update source is loopback, neighbor 3.3.3.3, remote AS is 10. Now if neighbors are physical interface IP address, by this time it would have formed neighbor. Because it's a loopback interface address, it is not matching with the incoming source address. That's why they are not forming neighbor. See, show IP BGP summary command. This will show the neighbor status. There is a neighbor called 333 and it has never formed neighbor. The neighbor has never come up. Idle state is not good. Idle, active, these two are not a good state. I'll debug and show you. Debug IP BGP all. Do we have all command? All, yes. All command. First of all, TCP should happen. See, what happens is this is trying to send an open message to 3.3.3.3 and the local address is sending the sent local address is 13.0.0.1, Whereas on R3, the local address of the neighbor, the address of the neighbor is not 13. The address of the neighbor is 1.1.1.1, which is not matching. That's the reason this is not forming neighbor. It is going from idle to active, active to idle. It will not form neighbor. So what is the solution? Instead of sending the local address as 13.0.0.1, I should send local address as 1.1.1.1. How it can be done? We can do like this: router BGP 10, neighbor 3.3.3.3, update source is loopback 0. Similar commands should be given on the other side. Neighbor 1.1.1.1, update source is loopback 0. When we say this, see, neighbor immediately comes up. Let's do the debug once again and see what happens. I'll do the debug again, and also I'll refresh BGP. This is the command to refresh. Clear IP BGP star. See, I cleared BGP. Now you see the local address. The local address is changed from let's go top. The local address is changed now from 13.0.0.1 to 1.1.1.1. Because we used the update source command, it changed and it got matched with the neighbor statement. So show IP BGP summary, you can find the neighbor is up for last 29 seconds. Alright, so now we saw how to solve the issue when we have loopback interface address as the neighbor address. In iBGP we have seen it. Now next thing is between eBGP, we are going to see show IP BGP summary. Now as for now I have only one iBGP neighbor. Now I am going to configure eBGP neighbor also. Router BGP 10, neighbor is loopback interface address of R4. Remote AS is 20. So what BGP will do, it will compare the local autonomous system with the remote autonomous system. Because it is not matching, then it understands that this particular neighbor is an eBGP neighbor. So it will send the TTL value with 1. I'll show you this once we finish this. Or before we do that, let me show you on R1. We already have R1 established neighbor with R3. So type show IP BGP neighbor. You can see that this is already established the neighbor with router 3, and keep alive are 160 second every 60 second, and I want to show you the TTL value. Look at this. When it sends the TTL, when it sends the packet out, it sends with the outgoing TTL of 255. Whereas with eBGP it will send with TTL of 1. I'll show you that in a moment. So going back to router 3, and router 3, what else I need to do is I need to say update source. You remember, I need to say update source loopback 0. I need to do this. Similarly on R4, let us go and do the same. Router BGP 20, neighbor is 3.3.3.3, remote AS is 10, and to this neighbor use the loopback interface address as the update source address. So these are the two statements. We did an IBGP and it formed neighbor. But now it is not forming neighbor. The reason, there are two reasons. Reason number one, R4 don't know how to reach 3.3.3.3. If it is not reaching, then it cannot establish TCP connection and BGP won't come up. So we need to either write a static route or run a routing protocol between R3 and R4. What we will do is we'll write a static route. I'll say IP route 3.3.3.3 255.255.255.255. Send the traffic to 34.0.0.3. There is also another route which is 43. Done. Similarly, on R3 I need to write route to reach 4. So I'll go to router 3 and write IP route 4.4.4.4 255. Send the traffic to 34.0.0.4 and also send it to 43. Sorry, this is what? No. We are just writing static route. We are telling R3 how to reach this address. Why I should say that? Because that is the address that is used by BGP to form neighbor. So if you say 4.4.4.4 is your neighbor, you should say how to reach it. Now, no redistribution here needed. Now I'm going to ping from here 4.4.4.4 with a source of. If this ping is happening, yes. Now BGP can send its packet because it knows how to reach the neighbor. I want to debug and show you before we do one more step to finish this configuration. Again, debug IP BGP all. You see, the open message is failing. Why the open message is failing? It is sending with a TTL of 1 to this address. From R4, it goes with 1 TTL value of 1. As soon as it hits R3, it is not finding where 333, so it expires. Why? 333 is not on the physical interface, it is on the logical interface. So it needs some more time to breathe and find where is 333. So to do that, we increase the TTL value. Now before that, let me show you show IP BGP neighbor. Here I'm not seeing neighbor. Neighbor is not established. It is in idle state. The reason is it is sending with TTL of 1. So I'm going to increment the TTL. After incrementing the TTL, you will find this 2 forming neighbor, and then I'll come back here and show you the incremented TTL value. Router BGP 20 neighbor 4. Neighbor 3.3.3.3. To this neighbor, send the TTL value, eBGP multi-hop. See, put question mark. It says, what is the maximum number of hop count you want to send? I'm saying TTL value 2. Let it be 2 hop. By default, it is 1. If it is 1, it won't form neighbor because eBGP neighbor need to be directly connected. So I'm incrementing 2. So again here I'm going to say neighbor 4.4.4.4 eBGP multi-hop 2. After I say this, When I put this debug command, you will see they form neighbor. A neighbor is already come. Neighbor is already up. I want to show you debug IP. Sorry, no more debug. It is already neighbor now. Show IP BGP neighbor. I'll show you that the TTL value is now 2. Outgoing TTL is 2. By default for eBGP it is 1. That is not enough to form neighbor. If your neighbor is the loopback interface address of the neighbor, so we need to increment the TTL value. Now, is the BGP established? Yes, I can see here. R4 says it has established the neighbor with router 3. So same like OSPF, BGP also uses router ID to identify, but this is not spoken much because it is TCP protocol. When it comes to attribute, router ID is also one of the point in attribute. We'll talk about that when we go attribute. Attribute number 8 talks about the router ID of the neighbor. We'll talk about that when we go there. So hope you understood, how eBGP and iBGP differs, and what is update source command means, what is eBGP multi-hop means. We'll stop here now.